Hello? Hey, Michael.
Hey, how are you?
Good, good. Hello, Sheree.
Hello, everybody. Hello, Alan.
So I created an agenda. Do you want to take a look at it and see if we can flesh it out?
Let's do it.
Okay. Let's see.
Can you? Well, you don't have to do anything. Let me go there and fix it. Okay. That's good.
I wonder if it's too difficult to find information about the community meetings on our website.
I don't think so. I think it's just a matter of making time for it. I really don't think.
Because it's like hidden in like getting started.
Oh, actually, it's there on the front page, no?
Oh, at the bottom.
Yeah, it's there on the landing page. We can do something else also. We can, if you go to Knative,
Yeah.
the new shiny new webpage inspired by our webpage. So if you go to the Knative webpage, you will see on the right top there is a link to community. So we can create the same thing. Oh, Hi is asking it.
Yeah, I haven't seen the new Native website, but I was also thinking the same thing. Like maybe there should be a dedicated tab for meetings, just to really showcase that we do have these meetings. Because I also have to join from another computer so I can record this meeting, but I click contributing, and then I have to scroll down a full page, then click on enter community meetings. And then I finally get to community meetings, and it seems like there's a few steps.
I see.
Yeah.
I think I agree. I agree. We don't want few steps. We want one step. Yeah. Yep.
Okay, that's something we can consider do. I can do that.
Okay. Yeah. Hi said he's stuck in the join. I think it's maybe because he has a wrong link. So that means that is also an issue. So if he has trouble finding the right thing, it means others will help.
I decided to do the test. I went to the website. I went to Meet, and I was able to get here from there. So that worked.
Okay.
Yeah, I did the same.
Yeah, I also see that we no longer have like a hyperlink to this meeting in the Iter8 community meeting description. So I will also add that in.
Yeah.
Make it easier. Yeah, it's okay.
Yeah. So I think we want it in the web page. You're right, What we don't want is in the Slack invites. Sometimes we send these Slack invites for meetings in other communities. There, I think we want the calendar link. I don't think we want the meeting link. That's, I think, the right approach. So, because we want people to get this thing on their calendars. Okay. So we have an agenda today. I think we discussed this a while ago. We want to discuss local experiments with Iter8, and I can lead this part of the discussion. And Michael, I think, is going to present Kubernetes experiments. So are there other things in the agenda that we should add, or can we split the time this way? You're okay with this? Then we can split it this way.
Yep, sounds good to me.
Let's do it. Okay, so 30 minutes, 30 minutes. This meeting is going to run out on time, so I'll probably make my part 23 minutes. Let's say 23 minutes. Okay. So let's get started. And there may be some objectionable Slack messages and stuff like that, so do not disturb. Okay. So, can you see my screen?
Yep.
Yes.
Okay, so, this is all, everything here is development version, right? So all the demos today is going to be through the dev branch, and our local stuff on top of the dev branch. That's how these demos are going to be. But already I kind of created this makefile inspired by our existing makefiles in the Iter8 project that I think Michael put together. So this is kind of taking off from there. So there is a makefile now, and let's go ahead and build Iter8. So as we know, Iter8 is now a command line utility which you can use to run experiments locally and remotely. So you can build, and it will give you something called an Iter8. Now you have Iter8 locally. So I'm just demonstrated a local build right now. Okay. So there is also this test data folder right here in the project, and it has some sample experiments. That's what I've been using for testing, local development, and will also use for this local demo, right? So the demo that I'm going to do is something that probably have seen, not all aspects of it, but some aspects of it we've seen before. So I'm just going to, first of all, we said we have an Iter8 CLI. Let's look at what the commands supported by the CLI are. So there's an assert command, there is a gen command, report command, run command, and hub command, right? So these are the main commands. Report is for kind of like our Iter8ctl, has a describe command for describing experiments. Report is essentially the same. You can report results from an experiment in a way that is consumable. That's all the idea is. And gen is really our templating function, right? So there are there's a custom generating feature that I also want to demonstrate as part of today's demo. Assert is something that I think all of us are familiar with. You can assert conditions on the what happened during the experiment, including whether the experiment completed without failures. And hub, I think we demonstrated before, but essentially it is a way to download experiment folders from the Iter8 hub. So there is a default public Iter8 hub, and people can create private hubs also. So if you go into hub, you see that there is a default Iter8 hub located here, located in this location. But if you want to create a private hub, you can do so as follows, where you can host your own experiments and do your own things, and it will be available as part of the hub command. Okay, so that's just a little bit about iterate top level commands. We are about to run an experiment now, so let's take a closer look at run. This command will read experiment spec from a local file called experiment.yaml, and it will write the result of the experiment into another local file called result.yaml. So there are two files, one for the spec and another for the result. Okay, so let's take a look at experiment.yaml, which we are about to run. We have seen this a few times. Oh, there is one twist here. So let's see. Generate, load, and collect metrics is going to do that for this URL. So that's where my application is running. It's a public URL and it's a public application, exposed publicly. And this is how I'm going to assess my application using these SLOs. 95th percentile latency under 100 milliseconds, and error rate is 0. But the twist here is that we now have these if conditions. So if SLOs are satisfied, in other words, if these conditions are found to be true, then do something. If they are not satisfied, do something else. That's the pattern that this experiment is demonstrating. And this is obviously useful for rollout and rollback, right? That's the whole idea. So you can verify SLOs, and if they're satisfied, here I'm doing something pretty lame. So, but you can do more sophisticated, maybe a kubectl, apply a new version, or roll back an existing version or whatever. So all those are possible here. This is just a simple demonstration. So I want to keep this post experiment hooks a little bit simple, but you can really run whatever you want as part of these tests here. Okay, so let's give it a go. Export. Oh, you can, by the way, you can also set log levels so that you control the level of verbosity in this experiment as it runs. So let's make it info, which is the default, looks like, and iterate run. Okay, so we are beginning to generate, load, and collect metrics for example.com. And done. So we have assessed. So task 1 is this, collect load completed, collect metrics completed, task 2 assess versions completed, task 3 run started completed, task 4 skipped. So why did it skip it? Because if you remember, our task 3 is saying SLOs, task 4 is saying do it if not SLOs. So it got skipped because this condition evaluated to false. In other words, the SLOs are satisfied, so no need to run task 4. So the task simply got skipped. Okay, so that's about the running of the experiment itself. Now we have the results. As we said, we can do a few interesting things. We can assert conditions like what? Like this. So we can assert conditions like this. Let's see, let's assert these conditions. Looks like experiment completed, it has no failure, and all the SLOs are satisfied. That's the condition that we wanted to assert. Okay. There is also a timeout feature here. So I think this is useful if you have a long running experiment running in the background maybe, and you want to assert something in the foreground, or if you have a remote experiment, again, long running, and you want to assert something in the foreground. I think the timeout feature is useful for scenarios like that. Okay, so we asserted something. We also said we can do reporting. So let's understand the reporting functionality. There's a text report, and then there's an HTML report. This is how we generate text report. This is how we generate HTML report. The -o text option is optional because by default it is -o text. So let's do report. So this is again something you're familiar with. It's kind of like iterate CTL describe. So summary of the experiment completed, no failures. all the SLOs are satisfied, and these are the metrics. And iterate report minus o text is the same thing. Iterate report minus o HTML, this is the new thing. So a whole bunch of HTML is getting dumped out. So that's not what we want. What we want is like this, so that we can do this. Look at our report in HTML. Oh, ignore this beautiful diagram. For now, it's all mocked data, fake data, but pretty much the rest is correct data. So it is. This is the summary of the experiment. Same thing. SLOs are satisfied or not. I want ignore the formatting also. I think I'm using a Bootstrap default template. I didn't want to put a lot of effort into this at this point. So just using some defaults, it's super ugly. But there are some simple ways to clean up this HTML so that it looks less ugly. So that's kind of not the priority at the moment. Anyway, you have a summary of the experiments. You have a summary of which SLOs are satisfied and which SLOs are not satisfied. In this case, we know all the SLOs are satisfied. And there is concept of histogram metrics because our built-in metrics collector actually collects latency histograms. That's what we will end up seeing, and you will end up seeing something like this, not as pretty, but more real. And the actual metric values, not just for histogram metrics, but every metric that is getting collected in the experiment, you will see the metric values here. So you see some metrics have units, some metrics don't, or unitless. That's what you're saying. These are all built-in metrics, right? So we didn't actually, you're not reading this from databases. These are all client-side metrics collected by Iter8.
Another output that you had was a results file too, right? That was something that scripts can easily parse. To John Dumovic's question last time we talked to him. Is that right?
So absolutely yes, absolutely yes. There is a result.yaml, although it is unclear to me why a script would ever want to parse this file. So that's a part that I don't understand.
Yeah, well, his point was if you inject iterate in stages of a pipeline, you might want to, I don't know, you might want to do things based on the results of the experiment, based on the file. So, you know, I think the limit is the creativity of whoever is doing that, right?
Exactly. So that's, technically, is it possible? Answers, of course it's possible because we are dumping out a result.yaml file, so do whatever you want. But our recommended approach for doing such stuff would be to use the assert command. So this is created exactly for that purpose.
Right.
So you can, and it has very semantically sensible conditions that are exactly doing this, going after the YAML and asserting conditions in the YAML. So if there are more conditions that need to be added, we are all ears. And if there are existing conditions or enough to do what the user wants, this is definitely the recommended approach for doing that particular thing. Okay. So let us do one more thing. What was hiding here under the covers is this gen command. We didn't really explore this command yet. So it's a templating feature that Iter8 has. So I want to take a few minutes because we are working on this code engine project also. So we have a few interesting use cases for Iter8 templating features. So this part of the discussion is motivated by those kinds of needs where we do want to use templating, right? I think Michael is going to show a sort of a different take on templating for Kubernetes experimentation. I'm also going to essentially motivate this part by Kubernetes experimentation, but don't read too much into the Kubernetes experimentation part here. I am not going to demonstrate the Kubernetes experimentation part, but really focus on the templating part. So let's pay attention to the templating feature here. Okay, so Iter8 Gen, as I said, is the templating engine. And there are two types of templating subcommands available here, right? So you can template, you can create an experiment template. So there's an experiment TPL file, and then you can create a more raw Go template file. Both are Go template files. However, when you create an experiment template and use this subcommand, when you use, iterate gen exp subcommand, there is an expectation that the output generated by this command is an iterate experiment spec. So that means iterate can validate it. Iterate can do some nice things, and if there are some problems with the spec, it can emit errors right at this stage before you go any further. So there's a little bit more of validation. There's a little bit more of expectation of what iterate gen X is going to produce as output. With Go, it's just a raw Go template, so it can still have errors, but it will be it'll be like at the level of string parsing. There's no concept of there's not necessarily any concept of an experiment using this Go command. But we'll see why it's useful in a second, right? So the way it works is it reads a file called go.tpl and produces a custom output. And I believe I have an example go.tpl file, which we can take a look at to understand why we want this. Okay, so here is actually a template file that has something like a Kubernetes job. It has something like a secret. It has something called role bindings and all that. So let's actually try to run this and see what happens. Iterate gen go. Oh, I need something called a name. It doesn't have a name. So let's just set name equals hello and see what happens. Oh, it generated something. What did we just do? So if you're familiar with Helm, if you work with Helm, you must be very familiar with what I just did. You have something like a Helm template, and we are producing output out of that. And there are some differences here between a Helm template and this iterate template, which is obviously inspired by Helm templating. So let's see what those differences are in a second. But at a high level, you have a template, and you're able to set some values for that template and generate this kind of an output. So essentially, if we go back to our code engine use case, that's where the whole thing started. If you want to run iterate in code engine, which incidentally is an IBM public cloud service. So if you want to run iterate there, you can create a code engine job, and you can create a secret. Code engine understands secret. You probably don't have to create roles and role bindings because code engine seems to be set up to work with default roles and role bindings well. And that's all there is to it. You can create a job, you can create a secret, and the job is using that secret. Secret contains the experiment spec, by the way. So secret contains the experiment spec. The job is using that secret to read in the experiment spec, create a file out of that experiment secret, run the experiment, and create another secret containing the results. That's what this job is doing. This is actually a proper Kubernetes job. So I believe if you run this whole thing in Kubernetes, you apply this, it will start running. That's my understanding. I haven't tried it, but that's my understanding. But this is the whole idea. There is an iterate image, whatever command line I just showed you, whatever program that I showed you, executable, is wrapped into this image. And the experiment spec that I showed you is wrapped into the secret. And there is a little shell of a program here that says, get that experiment, run that experiment, and push the results of that experiment back into Kubernetes as a secret. That's the whole gist of this output. So there are really no assumptions on what this Go template is. It doesn't have to be anything even iterate related. It can be anything in general. So it's just a template, Go template, and which has some placeholders. And those placeholders need to be set for it to work properly. So because we are asking for name here, we are asking for name here and here and here, so on. The suffix is a variable that is set randomly here, but name is a variable that this template is expecting. So if it doesn't get it, it's going to error out, which is what I showed you. But if you set it, then it's going to produce a nice output. Questions about this particular templating feature in terms of, first of all, why it is there, and second, what it can do. You can really create any template out of this because it is just any Go file, Go template file.
I don't have a question, but I have a comment. I think that we should demonstrate this with something other than a Kubernetes job.
A code engine job, that's the main target for.
I know that's the target, but I think for demonstration and documentation purposes, we shouldn't put the job.
I agree.
I think it confuses the Kubernetes use case.
I agree. So I know where you're coming from, and I see that. So I agree. That's why I kind of, give all the disclaimers at the start, saying don't read.
Yeah. No, I know.
Yeah.
I don't know what a good example is. This is a good example. Code Engine is a good example. But I think from a documentation perspective, it becomes confusing later.
To be really honest with you, I don't even think this needs to be a documented feature. If we are not even making it public, we don't even have, if it's only a code engine use case, then it doesn't have to be a documented feature. It can be an undocumented feature. It's definitely possible. That's an option also. I wanted to take this time to, obviously discuss this because Alan is working on these kinds of things. So I just wanted to make sure this feature comes across clearly for Alan's use case. Any questions, Alan or anybody else, on what we just did with this whole thing in terms of templating?
Nope. I actually already tried all of this. It seems to be working.
Okay, that is fantastic. Now, if you tried all that, did you get a chance to look into its documentation? Was it useful, or were you able to do it even without it? What do you say about that?
You mean documentation outside of the help command?
So there is, yes, essentially the same documentation is here.
Also. Oh, right. It's you have generated.
Yeah, that auto-generated documentation is there in the user guide for these commands. So if you already tried it, that means I don't think you could have gotten it to work without reading the documentation. Or is it so easy that it just worked for you?
Well, I kind of just played around with it. I was a little bit confused by, for example, the command requires experiment.yaml, but in the test data directory of the v0.8, there's nothing named experiment.yaml. There's just experiment.kn.yaml. So I was a little bit confused about that. Or
I see.
But just playing around with it, renaming some files, I was able to get it to work. So yeah, I do wonder if we should add a functionality where you can specify a file name, right, or a path where it'll read that experiment, because that'll also make it easier to, for instance, if we want to reference these files in the test data directory, it'll be easier to use them. We don't have to require the user to rename the file.
We will come back to this point, right? There are, I think, pros and cons for exactly what you suggested. This question has come up. It has come up in the past. But if you look at many of the systems, including Helm and including Customize, they all have certain conventions that they impose, right, for file naming. And they expect those files. If it's not there, it's not there. You just won't be able to go forward. That's all. So the Some of the files, I think we can impose certain conventions. Certain other files are not even, this kn dot, these may be temporary. These may not even be a real thing and may go away when we push, when we merge into Iter8 master. Some of these things may actually go away, precisely for what you're saying. It is causing confusion. Maybe it's better kept as separate, hub folders elsewhere.
Yeah, I think maybe one solution is just to divide the test data folder into smaller directories, right? Because I also had a similar issue with because, well, I'm not really sure what we had in mind for test data, if this is supposed to be for reference for users. But I wanted to keep the old Go template file, right? But also add my own, which has the code engine job run, right? And so I had to rename this one to like old Go template, so I can still keep it, for easy access, and then create a new Go template file. And it's just like not the easiest to work with, knowing that there's so many other different files going on here.
Yeah. So I hear you. I think subfolders definitely is this quickest and easiest option. We want that. So we can work. So one thing I know for sure is this is not the final test data. Okay, that I was always clear about. What do we want out of it, and how is it going to look? It's still evolving, right? We're still in the local development mode. So I think in a 3-4 days time, this will hopefully look much less confusing.
Yeah.
All right. So I think I want to hand over the baton to Michael.
Okay. Then let's look at the Iter8 CLI as it would apply to Kubernetes. I'm going to spend less time showing the help because I haven't put in the same effort that we saw, the refinement that we saw from Sri. We can look at it. What I have done is we have, in addition to the base CLI, now we also have a K8s subdirectory that has the commands for Kubernetes. In general, they extend the existing base CLI commands. And when we build this, so it's not in the make file, but we build it in the same kind of way. Target again is called kubectl-iterate. And what that does is it creates then a Kubernetes plugin for us. So I've actually got now a Kubernetes plugin that I can call kubectl-iterate and get a list of commands that are available to me. And you can see that they're the same set of commands. There are a couple new ones. There's a get command to get a list of running experiments. And I have a logs command to see the logs from the experiment execution. When Sri showed us the experiment, it showed the log right on the screen. Since it's running remotely in the cluster, you don't get that. Instead, you can use the logs command to get that. The other commands are the same, are similar, the same. And I have a deprecated command that I still have to take out. So let's go ahead and go to test data, and we'll try to run exactly the same experiment using the same, I think it's the same experiment YAML. Now mine is a bit older, I guess. So I thought I had merged the changes, but perhaps I did not.
It looks the same to me.
Okay, great. So let's go ahead and run it. Now the problem is that if we can do this, we can call iterate run. And if we do this, in fact, we will run the experiment locally in exactly the same way. Okay, I apparently broke it yesterday. But that is the way it's designed, is when you call run, it runs the experiment locally. If you want to run it remotely, then what you need to do is you need to, in fact, call the gen command that Sri showed us, but call it with requesting something in Kubernetes format. And what that will do is generate very similar to what he showed us, because it's the same concept. You're starting with a Go template, and you're going to create a secret that contains the experiment. Two secrets. One is the result, an initialized result, which is kind of empty, and then the secret. I'm sorry. There we go. I didn't see it here. So one secret, which is the experiment itself with the experiment as part of the data of the secret. A second secret, which is an initialized result. A Kubernetes job. In this case, you'll see that the behavior of the job is a little different. And then the roles that are necessary to allow the job to read and write the secrets. We'll come back to this and why it's different after we go ahead and run it. So what we'll do then is we generate this and we apply it to the cluster. And we see just those same objects being created, the two secrets, the job, and the RBAC information. We can now go ahead and see what experiments exist. And we can see that there is currently one experiment, and we have some summary information about the experiment. Has it completed? Has it failed? How many tasks are in the experiment, and how many of those tasks are now completed? And so if we get it again, it's still running. Okay. And now it's done. So it's very quick once it does get started. There is a delay because, again, we're starting a job. The job needs to fetch the image. The image needs to, pod needs to start, and so on.
Hey,
so what I said is...
Quick comment. I couldn't help but notice that the headers also have white spaces between them. Spaces between them, and it's a little bit confusing because there's completed, this is the second column, num tasks completed, this the final column. I think it may be helpful to either underscore them or put a hyphen between them or something like that instead of put a space between num and tasks. So column 1 becomes the name, column 2 is completed, column 3 is failed, column 4 is now minus tasks, column 5 is now minus tasks minus completed.
Yeah, that seems like a good idea. I mentioned the logs command. So the logs command shows us the same output that we saw if we just ran the command locally. So it's going and fetching the log of the local execution. What else do we want to see? So we also saw that we can run assert. And we can see, is it completed? And there is an issue here that I need probably some help, Sri. Completed, -C, no failure, -C, SLO, so same command. And I seem to be getting the opposite to be true. And I don't know why.
It may be that SLOs are not satisfied. That's okay.
No, I consistently get this. And let's have a look. And this might be broken because I just noticed it a minute ago that there's a problem with report.
Hang on. Isn't your assert doing a remote assert?
It is. Now,
No.
what does that mean? It is. Now, what does that mean? So let's talk about what it means when we're doing all of these commands are remote. What does that mean? It means that when we call assert, we are fetching the experiment and the result from those secrets in the cluster. And we're using them to build an experiment object and running the assert on that experiment object. This is different from the local case where we get the experiment and result from files, build an experiment object, and run the assert on that. We're doing the exact same kind of thing, but we're getting the experiment and the result from somewhere else.
No, I'm saying your assert command is actually you provided a local assert command. You did not give the -- remote option.
There is no -- remote option. So the way these work, again, the run command seemed to be broken locally, which kind of surprises me. I could show the way you do these locally, but I don't know why is this broken. Okay. So this is the way I would run the local command, and it's running exactly the same way we saw it run earlier, correct?
Yeah.
So because it's a Kubernetes command, oh, crap. Sorry. I haven't run the local examples very often, and so
let me understand this, Michael. When you do a get, what do you do? What happens? Do you actually create a local file as a result?
No. So a get. Oh, I have the old documentation too. What the heck is going on here? Let me show you the assert. So the -c is something that we had before. The -t is something we had before. There are two new options here. Okay, there's a -e, which allows you to identify an experiment. If it's not specified, the most recently created one is being used, and that's what I've been doing. So I've been assuming this. You can also use a -l option or -local option, which means we execute it locally. So in order to get the same behavior as you saw from iterate assert, when you're using the Kubernetes plugin, you would use it this way with the local option to assert that you're executing a local experiment, an assert on a local experiment. And the same is true for reporting. You're reporting on a local experiment. And the same is true for just these two. So the others, the context is local no matter what. So hub, run, gen, these are all local contexts to begin with. Get and logs are remote contexts always. Assert and report are the only two that can be applied to either a local experiment or a remote experiment. And so we use the -local flag when we're doing it locally.
So Michael, why does your iterate run requires a result.yaml file if you were to run it locally? It seems to be crashing on that.
It does. It does. I don't know why.
I think there's a code.
I may have an old version of the code.
Yeah.
So I think Shri, you merged the code last night?
Yeah.
Okay. So I did not update my code this morning.
Yeah, that's okay. That's okay. One thing is, you showed somewhere dash remote option.
So let's talk about that one. So this is a special case, and this is the approach that I took, and I'm not sure it's the best approach. But in our Kubernetes, our generation for Kubernetes code, we have a template that we use. The template is built into the system, but this is what the template looks like. And the execution is that it uses this command. Now, Sri, you showed us an example where you read the secret and you created a experiment.yaml. And then you ran the local command, you ran iterate run. And then when the experiment was finished, you did, you read the result.yaml and you wrote it to a resulting secret. I decided that this was not the best approach for remote execution, because what it does is it does not create a result secret until the experiment is completely finished. And we envisioned that the remote experiments will be run, for example, for long-running experiments. And in this case, the user has no way to get any information about this experiment until it is completed. What we really want is a run which each time it updates the result, it doesn't just update a local file, but rather updates the secret, the result secret. And so we can't just wait until the end to create the result secret. We actually have to create it immediately, and we actually have to update it throughout the course of the experiment. And we have a mechanism in our execution to do that. Each time a task completes, we are updating the status of the experiment. And we can do that with a file, or we can do it with a secret. So the code is there to enable us to do either. But if we use just the iterate run command, that's designed to write to a file. The question is, how do we say that what we really want to do is, in the context of the job, we are running a local experiment, but how do we indicate we want that local experiment to use a secret instead of a file? Okay, and so what I did was I added this notion that, run is a local notion. I added a notion of a remote option where you can identify an experiment, which is essentially saying run the experiment locally, but use the remote secret, the remote definition of the experiment. Okay, these are options to the run command, but they are not visible options. They are not options that we share with the user. So they're undocumented options. But they're a way to run an experiment using a secret in a cluster, as opposed to running it using a local file. Does that make sense?
Yes. So the motivation makes sense, Michael. So I think we do want this capability of being able to immediately update the results of the experiment, which is stored in a secret in the Kubernetes environment. So that, I think, makes sense. Having said that, I think you still want the experiment.yaml file local. So in other words, the remote is, the motivation that you gave is perfect. It's about updating results immediately. The spec is never updated, or it should not be. It should be Correct. A local thing. So I think we still want to download, quote unquote, the spec locally, run the local spec, just the way you would do in any local experiment, and keep updating. But the only way you can tell your code to keep updating locally is through the remote flags. There's no other way to disambiguate. So that also makes sense to me. So we can do that, but this is sort of a mixed option where we are reading a spec locally and a status remotely. So when we think about our current experiment.io mechanism, it assumes both are the same right now. So they're either both file or they're both secret. And so we would need to look at modifying that. Yeah, we have to discuss the design details here a little bit, right? The reason why I'm suggesting it is because then it becomes common code. The run becomes the same thing. Except for the result update, because it's going to use a different IO for the result update, the run becomes the same thing. So let's discuss that.
The run otherwise is the same. So the implementation of run, really what's changed is if it's remote, we define the way we access the experiment differently, and then we call run.
Yep. Yeah. No, I agree.
This remains the same pattern that we use elsewhere. Unlike, say, the hub command is not even implemented here, right? There's nothing to do.
Yeah. Now, the other comment that I have is that two comments really. One is it's not clear to me we need a logs command. I think it's just a Kubernetes logs under the covers. So I think creating our own wrapper around it means we have to test it. It's extra documentation, extra testing. I think you can just give a kubectl logs job / and provide the ID, the right ID for the jobs command.
No, so that does not work. So if you try this,
No. You have
a logs command looks for a pod.
No, that's not true. You have to try a different command, klogs job / try that. Yeah. That's all.
If I could type.
That's all is needed.
Okay. I misunderstood that command, and I agree with you then.
Okay.
Logs command is done.
Now, there is one more thing there. Get obviously we need, because without the get, we want to know what is running and what to get. So we need that. Now, there is one other thing, which is your assert and gem, they have a -- local option.
Yep.
And your run has a -- remote option.
Yep.
I would prefer it if your assert and gen also has a -- remote option instead of a -- local option. Number one, for consistency, and number two, because we absolutely want to encourage local experimentation. That's the easy path. That's how you want to get started with Iter8, because putting it into Kubernetes is one step farther out. It's more remote. And we want to make the getting started pieces, as simple as possible. If you can get started without -- local option, all the better.
So I agree with everything you said. The only downside is this notion of a plugin. The user expectation is the moment they use this word that they want this to be running in a cluster.
I have to disagree with that.
So
I have to disagree with that, because the user will expect what we tell them it is. It is not that you start, okay, maybe they came up with that expectation, but we say that if you run it this way, this is what you get. Even if the user is expecting, there needs to be some way of, this is meant for running Kubernetes experiments. We're just saying this is how you run the Kubernetes experiment. You run it with the -- remote option. That's all.
So, like I said, I agreed with everything you said. That's my only concern. I'm happy to change it. It doesn't really matter.
I think we want to make the getting started pieces the simplest, so that it's like drop dead stupid simple to get started. That's how we need to make it, without any one extra character also we don't want. So that's the spirit with which I'm approaching the getting started pieces, at least. Once they understand what an experiment is, once they understand the value of an experiment and they can craft it, I don't think adding a -- remote option for them after that, running it in Kubernetes, is going to be a headache.
So Sri, is the idea that eventually the only thing that the users will use to interact with Iter8 is the kube control plugin, or do we will also have the standalone CLI?
So I wanted to comment on the notion of kube control plugin. So I am running it that way, and I defined it that way. But the truth is that, this is, it is just a binary. Okay, and we can we don't have to run kube, iterate, whatever. We can just run this thing.
In other words, Fabio, there is absolutely no difference between the kube control plugin and the binary. It's identical.
Okay, so gotcha. So really, it's up to us to decide: do we actually want to deliver it and tell people use it as a kube control plugin, or do we just want to deliver it and call it Iter8 CLI, and they can use it to interact with Kubernetes or use it locally? Both are perfectly reasonable ways to do this.
And they're not mutually exclusive.
And they're not mutually exclusive. So I don't know which is really the best way to do this. I've been running it as a plugin just because I want to be sure that that still works. But it is just a binary, and we can deliver it and tell people just use it as a command line.
To me, the kubectl plugin adds 8 extra characters in the beginning of each command. And you did a great job by creating an alias called K, so it only adds 2 characters for you. And apart from that, once you have it in your system, there is zero benefit of the kubectl plugin. The real benefit is in distribution, right? kubectl plugin is another way through which we can distribute Iter8. That's the only benefit that we get. Otherwise, you get nothing for free by converting it into a kubectl plugin, except a new way to distribute it using crew manifest. That's all.
What's this way of getting the distribution benefit? You can download a kube plugin, a kube control plugin for free?
You can download a kubectl plugin through, there is a crew mechanism. Crew is the, some sort of a repo or a distribution channel through which kubectl plugins are discovered. So you can create a crew manifest, and that will make it possible for people to discover your plugin using the crew plugin of kubectl. Crew itself is a plugin, and you can use that to discover discover kubectl plugins. Your Iter8 plugin will show up when you use crew. And it's kind of a standard mechanism for distributing kubectl plugins. So if we are claiming that we also have a kubectl plugin distribution channel, we will want to use crew to do it, so that it's kind of a standardized. People expect this, right? If you have a kubectl plugin, they expect to be discovered through crew.
Is there a gatekeeper for putting things inside of crew so it's discovered?
I think so. Yeah. I think there is.
This is the command that gets used once you've discovered your plugin. This is the command to install it. So there is an index of plugins available. So this is what Sri is saying. This is a delivery mechanism that we would provide our plugin to this website, and users could then just use crew to install
I see.
the plugin.
So,
but when you look at how most people describe their plugins, they give instructions to do it one of 2 ways. One is using crew, and the other way is sort of the native way to install it, which you see here if you just look at the Kubernetes documentation, they tell you how to install a plugin as well. You name it a certain thing, you put it in the path, and you can use it. And so very often the instructions are download this binary in this place, and you have it. Or use crew. One or the other is kind of the documentation that's typical.
By the way, the call ends in a minute, so
yeah.
We'll wrap up there. So I think we need a follow-up, Michael, maybe for some of the lower level design, code level design sorting issues to be sorted out. So, but otherwise it looks good. Otherwise, I think it looks good.
Yeah, this was great. All right, folks.
All right. So we will continue.
All right, take care.
Yeah.
Thank you.